Hey everybody, so when we're solving a quadratic equation using the square root property, we have always 3 steps, which you need to memorize. Isolate the term that's squared, square root both sides, put a plus or minus on the right side to show 2 solutions, and simplify your root. Now, what happens is when we're solving a quadratic equation by doing the square root property, we may not need to do step 1. We may already have that square term isolated. And if that's the case, then we could just jump to step 2, which is square root both sides. So let's look at a quadratic equation where this is the case. In the PowerPoint, you see x plus 6 squared equals 49. So we know that that is, in fact, going to be a quadratic equation. We know by now in our head, if we took x plus 6 and multiplied by x plus 6, x times x would be x squared. Now, we don't want to do that. And let me explain why. If we took x plus 6 and multiplied it by x plus 6, that would be a binomial times a binomial, which we know would make a trinomial. And if we make a trinomial, then we'd have to set the equation equal to 0 and factor it. And that's not the method I want to do here, because there is a quicker way. So, what I want you to notice is, again, look at the equation. X plus 6 in parentheses squared equals 49. First question is, can you move that 6? Can you take the add 6 and move it over to the right side by subtracting? Absolutely not. Why? Because as you can all see, it's stuck in parentheses. So what I want you to notice is that square, that exponent 2, doesn't just belong to the x, it belongs to the 6. That's why it's in parentheses. So our step 1 is done. We already have on the left side who belongs to the exponent, the square termed isolated, because we can't move anybody. So now this is quick and easy to solve. If we can't move the 6 because it's stuck in parentheses and the whole left side is squared, we just go to step 2 and we say, how do we get rid of a square? Oh, we square root. So I square root at the left side, I square root at the right side. We all know square and square root are inverse operations, so they cancel out. So that leaves on the left side the x plus 6. On the right side, because we're square rooting and we put that symbol in, we put our plus and minus. Now, can we leave a square root of 49? Absolutely not. 49 is a perfect square. We know its value is 7. So now my equation is x plus 6 equals plus or minus 7. The problem is we're not done. Remember, the goal of solving is to get the variable isolated. But now if you look, the 6 is no longer in parentheses, so now we can move it. Now, here's my pet peeve. What I want you to understand is, what does that plus or minus symbol mean? That plus or minus symbol in front of the 7 means sometimes the 7's positive and sometimes the 7's negative. So what we need to do right now is rewrite this linear equation, because it's just good old x, as 2. So if you look, I rewrote. I have x plus 6 equals positive 7, x plus 6 equals negative 7. That shows me you understand what the plus or minus symbol represents. Now we can move the 6 by subtracting, and here come our 2 solutions. X equals 1 and x equals negative 13. So what I want to make sure you're careful of is you understand when you do the square root method, you are not guaranteed to always get the 2 answers being opposites, additive inverses of each other. I know in section 17.2, when we worked the square root method, that's what happened. One answer was a positive, one answer was a negative. In this expression, even though one answer is positive, one answer is negative, they're not additive inverses of each other. Okay, let's go to the whiteboard.